Oh. Oh, so I have only 23 students right now. I thought I had 138 now. What placements do you have today?
There's a company called Sahad Software. That
Okay,
test is
okay.
going on right now.
Oh, I see, I see. Okay, fine. Anyway, fine. The slides will, anyway, I'm recording and the slides are also nothing new. So next, yeah, the need for the database is one is that it is a structured way of storing the data. We call this a structured data, especially RDBMS is what we are discussing, right? And we've already seen that all the databases that we have discussed earlier was in the form of a relational form. When I say relational form, it is in the form of tables, which further means that you have rows and columns, right? Each of the column representing the properties of an entity, and the entire table is associated with the entity. And yeah, one of the advantages of having DBMS, or the need for DBMS, is because of its storage, the mechanism of storage, and for easy access of the data. When you know that you've already executed the SQL also. So when I give you the introduction now, you don't have to try to imagine something. You already know how exactly, how easily you could retrieve the data by writing very simple English-like statements, isn't it? Select of something, you would get the data. When you had to store, you had to write things like, insert into this particular table. So more or less, even your MongoDB is also very easy. Even that's even more easier when compared to your SQL. That's a no SQL, way of putting the data and extracting the data. Then the purpose of data, one is adding a data, removing the data, updating the existing data, retrieval, that is selection, and storing the data. So these are the ways, these are the mechanisms that is included when you say managing a data. When you say managing a data, these are the things that are associated with managing a data. These are few applications. I'm sure you'll be able to recall these slides. Then coming to data abstraction, this is something that we spoke about for probably 1 or 2 classes, where we have a physical level, logical level, and the view level. So if this entire database architecture is considered to have, it's a 3-tier architecture. So what happens in a 3-tier architecture? They are divided based on certain level of abstraction. Abstraction is some kind of hiding. Now, what are those levels? There are physical level, then you have logical, and you have a view level. In physical level, we are going to talk about how exactly the data is getting stored onto the hard disk. How exactly it is going to store on the hard disk. We are not talking in terms of the table structure. Both in RDBMS and in ADBMS, our concentration will not be on physical level. What we will be concentrating is on the logical level as well as the view level. We will not be discussing regarding the physical level. Physical level is associated with how exactly it is finally stored onto your hard disk. The data structures associated with the storage. See, when I say the data is stored in a table, I've already told you this before. When I say the data is stored in a table, in the hard disk, the tables are not getting formed. It's ultimately some kind of data structure which is used to store the data. So here the physical level is going to deal with that part, the data structure part of your data that you're going to store in the hard disk. Then you have a logical level. Logical level is the table structure where you're going to create the table. It's a logical structure. That's the structured storage where you're going to store the properties of an entity. Now, say, for example, a student database, or you take up an employee database, or a company, or a college, or some supermarket. So any data that you take into consideration, any entity that you take into consideration, we are supposed to form a logical structure for it. And those properties are associated with that particular entity. So that will form the logical level. Then above that, we have what is known as a view level. Now, view level is the one which all the users are going to, fit in. This is that particular level. Now, in this case, what happens is in this level, or rather, In this particular level, that is in the view level, we are going to consider the way in which you're going to interact with your database system. How exactly the user is going to interact. Now, see, when I say this is the example I had given earlier also, I mean, I've been using this phrase quite often now. So you have this table structure with, huge number of columns, and every user is going to access only few part. Let me, not take the student database. Let me switch to a supermarket. Now we have a supermarket and you have an owner there and you have some employees there. There are two categories of people. Okay. So, and you have a single table indicating all the items that is present in a store. And it is only the owner who can change the price of the item. Okay, and so which means that the entire tables edit and edit means, read and write both. So edit permission both to read and write lies only with the owner of that particular supermarket. Whereas the employee user, so I have two users now. One is a owner, the other is the let us say employee, the salesman. So the employee can only have the provision for viewing. There is only read permission. The read permission is associated with that particular view. Now here at this particular point of time, you can also consider the transactions part that you had learned. I think Rajesh sir taught that particular part, transaction management. So there, different kinds of operations, right? Read, write, you have, write, you have. So that kind of, operation, transactions. So here in this case of view, the user, I mean, the employee or the salesman do not have an access to write the data into the table structure. He has only the view provision, whereas the owner has the provision for both reading and writing. So that based on the user, what kind of view is that particular user going to get is involved or is described by what is known as the view level. At this particular level, the user is going to identify that. See, in this case, I just spoke about read and write. There are chances where only few part of the table is being seen. Let us say the logic of the owner. See, when a person is doing a business, definitely the cost price and selling price would be different. So the employee or the salesman need not know what is the cost price. I hope you understand what is cost price. Cost price is, if I am a businessman, I buy it from somebody and I sell it to somebody. So when I buy, my cost price may be 100. When I sell it, definitely I would have a motive of making some money more because I'm doing a business. So when I sell it for 120 rupees, right? So the cost price is 100, the selling price is 120. So this cost price may be present in the table, which may not be seen by the salesman. So that kind of division or that kind of subtables are being formed in case of a view level. So that's basically to do with the kind of interaction the user is going to have. Different kind of user is going to have it, different kind of subtables. Now schema, yeah, this is one term which will be widely used anywhere you talk about databases, especially schema. When you say schema, it is associated with the design of a database. So any design of a database, or for that matter, design means schema. So here, based on the levels of abstraction, we have three schema. One is physical schema, logical schema, and the view schema. So in the physical schema, as I said, it is associated with the way the data is getting stored. How data is stored in blocks of storage is described at this level, the physical level. That's the design of the database at the physical level. What about logical level? It is associated with the table structure. Since we are dealing with RDBMS, the schema here associated is the table structure wherein you have rows and columns. Then we have the view level. View level is also a table structure, or it could be in the form of a UI. Okay, it usually is in the form of a UI where the user will be able to access only few or maybe full based on what kind of user he is. He'll be able to view that part. So, and this is basically a subset of a logical schema. View schema is usually it is a subset of a logical schema. instance of a DB. Whenever you talk about schema, the next thing that comes into picture is the instance of a DB. Instance of a DB means you're referring to the rows, the values that you're going to store in the table. That is your instance. And one more thing that you have to remember about instance and schema is that whenever you talk about schema, whenever you talk about instances may change frequently, whereas the schema is subjected to less changes or is changed less frequently when compared to the instances. Schema means your design. You're not going to keep changing or altering your table, isn't it? You're not going to alter your table, whereas instances at this particular point of time, probably I'll have some 5 records in my table. And as I'm entering, within few seconds or within few minutes, probably I'll add some more records. That's quite possible, isn't it? Where even when a shopkeeper, even when you go to a supermarket, let us say the table structure is intact. When somebody comes for the billing, the person is going to scan the barcode. So item number goes in, the unit price comes in, he just has to type in the quantity he has bought and the bill is generated. So which means that item number is present in a table, item name is present in the table, unit price is present, the quantity has to be typed, the price comes in, the computation of total price, total cost comes into picture. So which means that these 5 things are already present in your schema. That becomes your schema that we are not going to change. Today you have one table and tomorrow you're not going to have a separate table. It's the same table which has been used for a long time. But what about the instances? Today the shopkeeper may have some 10 customers in the morning hours. Then so which means that 10 is the instances, the number of instances in that particular table of 5 columns is 10 records. Probably by the afternoon he get 20 more people, 20 more customers. So which means that the instances within half a day it turned from 10, it came to 30 now. So instance keeps changing. Okay, that is the one which is frequently changed when compared to your schema. So these 2 terms you should be clear with. Yeah, these are 2 that was listed. Schema, visual representation of a database, which is a set of rules that govern a database. Data stored in a database at a particular point in time. So instance is always associated with a time. Then the second difference, formal description of the structure of the database. How exactly you're going to store the data. That is, the table structure is what is described here. And in case of instances, it is the value that you're going to give to those structured columns. Okay, when I say structure of the database, as I said again, Dbms, so it is columns. So all the values that you give inside the column for each of the column, for each row, that particular value is your instance. The last one does not change frequently, as we discussed just now. And this changes frequently. The instances change frequently. So that's regarding the differences between schema and instances. Dbms languages, we had learned DDL, we had learned DCL, DML and TCL. In DDL, that's the data definition language, and data definition language is associated with how exactly you're going to create your storage structure. When we say data definition language, it is associated with defining the structure of a storage. Okay, that's data definition. You're defining the structure. What structure are we talking about? We are talking about relational structure. We are talking about table structure. So what are the commands associated with DDL? The commands associated with DDL are create, you're creating a table. Then you have alter, where you're altering the created table. When I say altering the table, it could be adding the columns, it could be removing the columns, it could be increasing the size of the column, that is column width can be increased, or you can drop, you can totally remove the table at all. Probably, with time you may realize that there would be some table which you do not require anymore. So you can always remove that particular table. So that's everything is associated with structures. In DDL, we are not going to talk about values at all. We are not going to talk about instances. This is associated with schema. That is DDL. Schema definition is associated with data definition language. Next, we have DCL, data control language. In data control language, what we do is it is associated with controlling the access of data. Data control language. You're controlling the access to the data by two important commands which are called grant and revoke. Now, what are those commands going to do? Grant is granting the permission to whom? To a user. What kind of permission? To access a particular kind of data. Now, one example which all of us can relate to or all of us can have experienced is my favorite example. It's the AUMS software. I told you that the faculty, there are few provisions that are given to a faculty, few provisions, extra provisions that are given to a faculty advisor. So faculty advisor, see, usually faculty advisor is for a term of 4 years. So the moment the faculty advisor finishes her or his tenure, he or she would be categorized under the normal faculty, user. So his provision or his or her provision, extra provision, whatever they had, that would be removed. For removing, we make use of the command revoke, R-E-V-O-K-E, revoke. And otherwise, this is granting the permission. So you grant the permission and you revoke the permission. Then you have DML. Now this is the one which you very widely use. When I say DML, it is associated with data manipulation language. Now when we say data manipulation language, when I say manipulation, there are many commands associated, starting from inserting the data. You insert the data. Insert is a command. Then you select the command. Anyway, select part I'll tell you at a later point. Insertion, then you need to make any update. Any kind of updates can be done using the update command. Update is a part of DML. Then you can delete a particular record. You're not deleting the table, you're deleting a record, you're deleting the values. For that, you make use of a DML command. And so that's data manipulation language. Now, within this, we also have what is known as the select command. Now, select is the most widely used command, and this will come under what is known as a DQL, data query language. Now, some books may talk about it, some books may not talk about it. If I have to be specific about the select command is a data query language. Otherwise, also you can categorize. Now, DQL is a part of DML only. I mean, that's how most of the books do say. So in case DQL is not explicitly asked or spoken about, then you can always categorize the select under DML. Otherwise, to be very precise, select is a part of DQL, data query language. And the last one is transaction control language, which is TCL, transaction control language. Transaction control language. Transaction control language, in a nutshell, it is to do with control S and control Z or control Z. What do they do? Save or roll back, save or undo. So when I have to save something, I have to make use of commit in a transaction control language. There are two commands associated with TCL. One is commit and the other is roll back. We haven't executed this, I think. I don't remember doing this. Let me see. We'll do it this time. Okay. Commit and roll back. Commit is to save and roll back is to undo whatever you have done. So that's commit and roll back. And you'll be able to see this commit and roll back difference when we do our drop and delete much better way. There you'll be able to, understand and appreciate the work of commit and roll back. Anyway, we'll execute this and see this time. So that's regarding your database languages. DDL for structure of the storage, DCL for access control of the data, DML for manipulating or working with the values present in the data in the table, and DQL specifically for a select command, and select command is used for retrieving the data. And then you have TCL, which is transaction control language, associated with saving your transaction or going back, rolling back. Why we require this rollback and commit is for the reason that database has an inherent property of what is known as atomicity. That's the reason why we have this transaction control language. Oh yeah, we have all these things here. I thought I don't have it here. So these were the commands, right? DMS transaction control. And then coming to database architecture. Now, database architecture, we have a few things. We have the database users here. It's kind of put it in a form of a way the database architecture is approached. You have the set of users, you have the tools through which the users is going to interact with these components of database. You have a query processor, the first component of a database architecture which the user is going to interact with. The query is processed and appropriate storage manager is going to carry out their task, and finally it has been stored into the appropriate storage areas. It could be a data dictionary, or it could be indices, or it could be a data dictionary, indices, and the actual data storage. We'll have a brush up on these also. This is required actually. Yeah, database architecture, they have few these components: database users, then we have query processor, and we have storage manager. So here when you talk about database users, you have 4 different kind of users. One is the naive user, then we have application programmer, we have sophisticated users, and we have specialized users. When we speak about a naive user, oh, how did I go by this? 1 second. Oh, I think I missed that. I'm still in class. So we have, I was talking about the database users. So in the database users, we have the naive users. Naive users are the ones who need not know the way in which this particular software is built. The only interaction that the naive user is going to have with these database application is through the user interface. Okay, that is naive users. Then we have application. Now the example that I can quote is, 1 second, students. Yeah. So the example that I can quote here is the bank officials. When we go to the bank, you can see that all the bank employees they have a monitor in front of them. You go and ask, you make an inquiry, they look something, they search for something in the net, in the application that you're using, and they come up with whatever the conclusion is, or they give you pass the information. So there, who is the naive user? The employees who are working with the application. How are they interacting with that database application? Are they writing the SQL query? Let us say that you want to find out what is the balance that is present in your account. So what is the balance? So when you go and say your account number, let us say your account number is 001. So there the bank employee is not going to type select balance from account where account number equals 001. No, that is not what is going to happen. The bank employee is going to interact with the user interface. You all have done your database projects, so you know it very well. So they write it. They interact with the database application through the user interface, and accordingly the respective or the corresponding query gets executed, and you get the data. Which query is getting executed, or which other component is getting is involved in the interaction, and such kind of information is not going to be revealed to a naive user. Then coming to application programmer. Application programmer are the ones who write the code for the application. That is, they are the ones who are involved in the development of your program. Coming to the sophisticated users think about not only the regular insertion and deletion of the data. Besides insertion and deletion of the data, they would also try to optimize your particular data. They would think about optimizing your data. That part is taken care by this sophisticated users. Now, okay, in this particular syllabus, you also have, I had told you in your the RDBMS class, there was an interesting topic called query processing, which was not a part of your syllabus. Apparently, they had removed it. But interestingly, in your syllabus, let me just have a look. I think it is there. Yeah, query processing is there. So that's an interesting topic. So there you will get to know why these sophisticated users are important. Of course, the query processing is done by the query processor, but then how exactly it is being done, that is also told. And a sophisticated user will also think about bettering the enhancing the performance of your application in a much better way. That forms the sophisticated user. And besides that, they'll also try to extract data for analysis purpose. They would try to retrieve some kind of information from the uh, data that they already have. They would not be a part of the regular transaction, like insertion or deletion or such kind of information or such kind of transaction is. I mean, the sophisticated users are just not restricted to do only such kind of transactions where insertion happens, or if they do not. They are not categorized under the users who perform a day-to-day operation. Rather, they are the ones who are involved in consolidating and try to gain some kind of information, gain some kind of knowledge based on the data that is stored. And see now, one example that I could see in my life, in my experience in Amrita is, see, when I joined Amrita in long back, we just had one block of hostel for both, I mean, not together, one separate building for girls and one separate building for boys. Now, with time, we realized that the number of students in hostel were increasing, and based on, and suddenly, and it was decided that you require more number of buildings for to accommodate these increase in the number of hostlers. So how was this decision made? This decision was made by whom? By the sophisticated users. How did they do it? Based on the already existing data, right? So based on the trend that they saw that and usually sophisticated users generate some kind of visuals. What kind of visuals? Some kind of graphs and things. So based on that, they see that there is an incremental growth. There is the growth is incremental, and accordingly the decisions are being made. So basically, they are the decision makers. They contribute towards decision making. The specialized users. So that's regarding the sophisticated users. The specialized users are the ones who belong to that category of users who do not do the conventional transactional databases. Now, this I could associate with applications which are, applications which are associated with machine learning or artificial intelligence applications. Based on some kind of algorithms, the decisions is being made. You'll also be, I don't know if that is a part of yeah, you will be learning that probably in the next semester. There are certain rules associated with data mining and all. There's something called association rule. I will probably include that as one of the topics as we proceed with the classes. Now, specialized users, right now, if I have to tell you, this is a kind of they are the users who do not conventionally fit into the people who do just the decision making. They are the ones who contribute towards not only bettering the system, they do not, they try to come up with applications based on the new technologies based on the current existing ones. That is, they make use of the machine learning algorithms, artificial intelligence, to come up with a database which is not conventional. So that kind of users are categorized under the specialized users. So those are the users. Then you have the query processor, three important components. You have DDL interpreter, DML compiler, and query evaluation engine. DDL interpreter comes into picture only when the user submits a query that is associated with the structure of a table. That is DDL, data definition language interpreter. And what does this do? It interprets the DDL commands, and when the database, when the DDL commands are given, appropriate updates are being done in the data dictionary. And what is a data dictionary? Data dictionary is that part or that kind of that's a storage where all the information regarding a data or regarding a table is being stored. I hope you remember the term called metadata. Metadata is data about the data. So that metadata is present in data dictionary. So now what do I mean by data about the data? Data about the data means I'm talking about the table name. I'm talking about the number of columns that I have. I'm talking about the properties associated with each column, starting from name of the column, what kind of data type it is associated with, how many characters, or what is the allowable value associated with it, whether it is associated with any kind of key attributes, is it associated with any other constraints. So whether it should be many constraints like not null, unique, primary key, foreign key, so all such kind of or it is allowed to take only these particular values. If gender, when I give gender, it should take only M or F as letters. It shouldn't be taking any other. And when a phone number is asked, only allowable values are numbers, not characters, and it should take only 10 digits, no less, no more. So such kind of constraints are also being fed in the data dictionary. Then in DML compiler, the DML compiler will translate your the queries associated with the values in a table. So in DML compiler, what happens is the instructions are being taken and they are subjected to what is known as optimization. Optimization is picking the best query for execution. And why do we do that? Needless to say, it is for the better usage of resources. For optimal usage of resources, we perform this. We, in the sense, the database architecture will perform the query optimization. Yeah, query optimization is what I said. We will be having one session on this. Okay, query optimization. Then in query evaluation engine, what happens is it is going to execute the query evaluation engine, QEE, is responsible for executing the best query. When a user enters one query, one SQL query, this has equivalent evaluation schemes given in the database architecture. So whichever is the optimal one that has been picked and is executed by this query evaluation engine. So that's the job of a query evaluation engine. Then coming, so those are the three things: interpreter, compiler, and query evaluation engine. And then coming to the storage manager. Okay, you're able to recall this. Are you all there? I didn't even bother to interrupt in between. I mean, are you all following?
Yes.
These? Yes. You're able to recall them?
Yes, ma'am.
Yes.
Okay.
Yes, ma'am.
Okay. Sorry. Yeah. So we have the storage manager. In storage manager, we have 4 different storage managers. One is authorization and integrity manager. And then we have transaction manager, file manager, and the buffer manager. Now, these are they are a kind of software which are these are set of programs rather, which is going to perform some dedicated work. Now, what are those dedicated works? Based on the kind of work, they are named accordingly. When I say authorization and integrity manager, what they do is they take care of all the authorizations, they take care of all the integrity constraints. They're going to take care of, they see to it that when I say integrity constraints are being maintained, it means that, see, you all have executed already the primary key. You know what is a primary key, you know what is a foreign key. So when I give something as a primary key and you try to repeat a particular value, you get a message, isn't it? You get a message saying that integrity constraint violated or primary key constraint violated. So that, which means that there should be somebody who is going to check that, there is no repetition. Who does that? It is this particular part of the program. It is this program. When I say authorization and integrity manager, it understands the fact that I'm talking about a particular code. It is this code which checks the table for any repetition if that particular column is tagged as a primary key. So no repetition is allowed. The moment you see a repetition in a primary key column, then it prompts for a message to the end user saying that there is a violation of rule. Or it's just not for primary key, for any other constraints as well. This is going to take the role of intimating or sending a message, passing a message to the user. That's authorization and integrity manager. Then you have transaction manager. The moment I talk about transaction manager, the first thing that you should recall is atomicity. What is atomicity? Atomicity is do the entire transaction or complete the entire transaction or revert back to the state where you had started the transaction. I repeat, whenever you talk about transaction manager, you have to recall the keyword atomicity, and atomicity is the inherent property of database management system, which ensures that your transaction that you had initiated completes successfully entirely. In case there is a glitch in between, or in case any component in between fails, it goes back to the previous state where it had just initiated. It is not going to be stuck somewhere in between. So that's atomicity. And there should be somebody there should be some set of programs, some set of instructions which is taking care of this atomicity. It is the transaction manager. Then you have a file manager. Now, file manager is the one which is going to keep track of the allocation of your data in the hard disk, the secondary storage, how exactly the data is being stored. See, when we have an application, we also have to see to it that there is a good performance of your application. See, one very good example, or one example which all of us can relate to very often right now is our mobile phones, isn't it? Our mobile phones also, we store a hell lot of pictures and audio files and all the forwards and all. So at times what happens is I encounter this. So I get this message, storage space full. And when I see that there is a lot of data that has been present in my phone starts, the speed goes down. So what I do is I remove those data. So what is happening there? So there's a prompt there, storage space full, or I remember reading such message like, some of the applications may not work because your storage space is full, or it is getting full, something like that. So there should be some kind of code or some code snippet which is going to check even for the disk storage. When they see that they have crossed a threshold, or they have crossed a decent amount of storage has been, or they're intruding more space, that it is going to deteriorate your performance as in the applications or the system's performance. So that part is taken care by this file manager. That's again a program. So there is a prompting happens. And coming to the buffer manager, needless to say, the term buffer. Buffer is going to cache your data. Again, you've already done your architecture classes also. So the buffer manager is going to store your data in the buffer. It's going to cache. It is present in your cache. And if it is found, it's a hit. Otherwise, you say it is a miss, hit and miss case in case of a buffer manager. You're going to temporarily store the data in the buffer. And when the user is requiring this data, you can always fetch in from the buffer. If it is, so it becomes a case of hit. In case it is not present in the cache, it has an overhead of going to the disk storage and fetching the data, where you will have a miss. So when you do not find the data in the cache, you say it is a miss case. The case is a miss. So the system has an overhead. It has to undergo an overhead of fetching the data from the hard disk. So that becomes your miss. That's the role of a buffer manager. The last is the disk storage. So you have a data dictionary and the data. So data is your physical files, whereas data dictionary is where you store the metadata. And metadata, as I said, is the data about the data. You store all the information regarding the storage structure, what is the allowable data, all these are stored in the data dictionary. So any DDL commands that you execute will have a corresponding entry in the data dictionary. Whereas data, you're talking about the physical storage. You're talking about the actual data that you're going to store in the hard disk. So that's the architecture of your RDBMS. The data storage, the storage manager, the query processor, and the different kind of users. So that's a gist of the DBMS architecture. I hope this was fine with you all. Anyway, I'll be sharing the slides with you. So is this fine with everybody? Are you all there, students?
Yes, ma'am. Yeah.
Yes, ma'am. Yes, ma'am.
So you're able to recall when I spoke all those terms?
Yes,
Some of
ma'am.
them.
Yes, ma'am.
Yes, least a few of them.
Okay, few of them. I see. Few of them you could recall. Anyway, this is definitely a part of your syllabus, students. So you'll have to learn these. Okay, so you will have to learn these. I will upload the slides. And the next topic that we'll be learning is regarding the query optimization. That is something that you have not learned. So we'll do that next. And then we will go on with the advanced concepts. But let me tell you, tomorrow I will not be able to take a class because there's a clash with the first year students. So and I cannot adjust that class because that's 3 different streams are coming to one section. So I cannot really take the class. They have EAC, Triply, and MEC. So I cannot shift that class. And it's only for this Friday and maybe next Friday. After that, it'll be fine. They would be done with their second semester. I'm talking about the first year students. So tomorrow you'll not have my class. We'll meet again. I don't know when. I think Wednesday. Yeah, Wednesday, Thursday, Friday is the class. So we'll meet on Wednesday. Hopefully by then I get all the strength, the complete strength. The next topic is something that you have not learned. This, even if you look at the slides once, I think that should be okay. So shall we wind up for today? Is that okay?
Yes, ma'am.
Okay.
Yes, ma'am.
Yes, ma'am.
Okay. I just rushed through these topics because only for the reason that you have already learned these topics, and the slides are it's the same slides that I used when you were in your 5th semester. I can't believe the 3rd semester it's a 4th semester that you're going through online mode. Almost 2 years. Anyway. Hopefully at least 8th semester, you come back to the campus. We'll see. Okay, students then. Thank you. Thank you, students.
Thank you, ma'am.
Thank you. Have a nice day.
Thank you, ma'am.
Bye.
Thank you.
Thank you.
Thank
all.
you.
Thank you. Thank you. Bye.